Hello guys, welcome back. I told you today we were looking at the grade 10 chemistry, trying to simplify. So today, just to dig in, I want us to look at the electron arrangement using the SPDF orbitals. Electron arrangement using the SPDF orbitals. Then here we are going to go direct into the energy levels and the orbitals, the relationship between energy levels and the orbitals. So from the previous chemistry of 844, we were much into energy levels, but now for grade 10 we'll be dealing with orbitals and also sub levels, and then the principal energy level numbers. We are trying to move away from using the term energy levels. So an energy level is the broad area around the nucleus of an atom where an electron is likely to be found. A broad area around the nucleus of an atom where an electron is likely to be found. Whereas now an orbital is a specific area around the nucleus where an electron is likely to be found. That electron might be having some energy. So orbitals are being represented by the small case letters S, P, D, F, S, P, D, F. So orbitals are being represented by the lowercase letters S, P, D, F. Then orbitals are being found in sub-levels. These energy levels are further subdivided into sub-levels, and those sub-levels is where you are likely to find the orbitals. The number of sub-levels found in an energy levels are being equivalent to the principal energy level numbers. The principal energy level numbers, which are denoted by letter N. So we want to see the sub-levels which are there when we have the principal energy level number 1. So the principal energy level number 1 has only one sub-level. The principal energy level number 2 has two sub-levels, and also when n is equals to 3, we are saying n is the principal energy level number. So when n is 1, that is one sub-level, n is 2, two sub-levels, and n is 3, three sub-levels, 4, that is 4 sub-levels. So how many orbitals are found in each principal energy level number? The number of orbitals found is being we use the formula n is squared. If you want to find the number of orbitals which are found in every, so if we want to know how many orbitals are there, remember orbitals, we say they are being represented by S, P, D, and F. So if we are at n is equals to 1, then it means that is 1 squared, and that is 1 orbital. So for when n is 1, we have only one orbital. So what about when n is equals to 2? That is n squared, which is 2 squared, and then it means we have 4 orbitals. Four orbitals. So when n is equals to 3, that is n, that is 3 square, and that is 9 orbitals. 9 orbitals. I don't know if people are catching up. So we want to see if we have when n is 2, how many orbitals? We are saying there are 4 orbitals. So let's look at this one. Let's look at this one. So energy level, when n is equals to 1, we are saying we have only one orbital, and that orbital is represented by S. So that orbital is being named as 1s. So when n is equals to 2, we have two orbitals which is s and p, which are labeled as 2s and 2p. When n is equals to 3, then it means we have 3s, 3p, and also 3p. 3s, 3p, and also 3b. That's how they are being named. So let's know how many electrons, the maximum number of electrons which can be there in these different orbitals. If we have orbital s, the orbital s can only be able to accommodate on a maximum of 2 electrons. Orbital s can only accommodate 2 electrons. So orbital p can accommodate a maximum of 6 electrons. D can accommodate a maximum of 10, and also F can accommodate a maximum of 14. But these ones of the ones of D and F, we will not tackle them much in grade 10. That's why I'm trying to tell people that grade 10, that is the simplest of all. All you need to know is to understand the concept. That is how these orbitals are being arranged, and that is the information you need to know about orbitals. That is the information you need to know about the orbitals. So we have basically said that orbitals are being found in sub-levels, and these orbitals are being denoted by lowercase letters s, p, d, and f. And what we are saying, the orbital s can only be able to accommodate 2 electrons, p can only can accommodate a maximum of 6, d 10, and also f 14, a maximum of 14 electrons. And here we are saying now that these sub-levels found, the number of sub-levels found in this primary principle, or the primary energy level number, is the number of sub-levels is equivalent to these primary energy level numbers 1, 2, 3, and 4. So if when n is 1, we have only one sub-level. When n is 2, we have 2 sub-levels. When n is 3, we have 3 sub-levels. So can we look at now the rules? How are we going to name the rules of writing the electronic configuration using the SPDF orbitals? So number one rule we are going to use is the lowest energy levels. The lowest energy levels are being filled first. The lowest energy levels are being filled first. The lowest energy level is when we have 1s. So you fill first 1s, and then you come to 2s and 2p, and then we have 3s, 3p, and also 3d. How are we going now to fill? For example, let's talk of oxygen. We have oxygen atom. We have talked that I believe people have covered the content of atomic number. Oxygen atom has atomic number 8. How am I going to represent this information, all the electronic arrangement, using s, p, d, and f orbitals? So this is it. We are saying the rule number one. We are saying that the lowest energy level should be filled first before going to the next one. So we will fill first the first orbital. The first orbital is going to be filled, and that is 1s2, because we are saying s orbital can only accommodate a maximum of 2 electrons. After that, you move to 2s. we are going to 2s2, 2s2, because s also accommodates 2 electrons. So how many electrons are remaining? We are only remaining with 2 plus 2, those are 4, and then 8 minus 4, we are remaining with 4. So the next orbital we are moving to is 2p. Now that 2p will not be filled, then we have 2p4. That's where our electrons will reach. So we will move to first orbital 1s2, 2s2, and 2p4. 2p4. These are the maximum number of electrons found in every orbital. The maximum number of electrons found in every orbital, but we are saying for 2p is not filled because it requires a maximum of 6, and we only have 4 electrons remaining. Number two, the rules of naming this one. We are now saying if it was in-box electron arrangement, and I don't think if I've given you the information to know the maximum number of electrons which can be found in a sub-level. The maximum number of electrons which can be found in a sub-level, because we are saying the first sub-level can accommodate 2 electrons. We have the formula as 2n squared. 2n squared. 2n squared. So for this one it will be 2 times 1, which is 2. When we have n is being 2, how many electrons are there? That is 4. 2 squared, 4 times 2, 8. When n is equals to 3, that is 18. 18, very good. So let's move on to in-box electron arrangement for this atom of oxygen. The in-box electron arrangement for this atom of oxygen, this is what we are going to have. Don't know if they are seen. So we have 1s, 2s, 2p. So what we are saying, the lowest energy levels are being filled fast because they require low energy. So you have to fill them fast before proceeding to the next one. So this one, the first electron is represented by an arrow and an upward arrow. When you are bearing, you use the downward arrow. Same case to 2s, up arrow the first one, bearing down arrow. We are using opposite arrows because we are trying to reduce the electron repulsion. So that's why we are pairing this way, the opposite arrows, so that we can reduce the electron repulsion, or to prevent the electron repulsion. And then this one, when you know that now your orbital is not complete, the remaining electrons cannot fill that orbital. First, you split one electron all through, like this one. You just give it first only one electron, and then you start bearing. So these are how many electrons? 1, 2, 3, 4, 5, 6, 7. We are remaining with 1 for oxygen atom. That one will come here. That's how you are going to represent in the in-box electron arrangement. So we can try another one. We can try another one for which element? We can try for sulfur. Let's try for sulfur. Sulfur has the atomic number of 16. Sulfur has the atomic number of 16. Still, we are using the same formula. we are using the same formula. We said this is how we are going to fill. This is the formula of trying to fill these orbitals, or trying to have these orbitals. So when n is equals to 1, we have 1s. N is equals to 2, we have 2s, 2p. When n is equals to 3, we have 3s, 3p, and also 3d. Let me leave at that point. Or we can have also, when n is equals to 4, we have 4s, 4p, 4d, and 4f. But we are not at our level, we are only concentrated with the first 20 elements. So you start, when filling, you start with 1s first, the first orbital, 1s, because this is 16 and s can accommodate a maximum of 2. So we have here 1s2, and then you come to 2s2, you come to, like that, 2p6, 2p6. So remember, what guides you is the atomic number. So if the atomic number is very high, or the atomic number is large, like 16, you can be able to move, because already these are 10 electrons. These uppercase numbers represent the number of electrons in that orbital. So we have 2 plus 2 plus 2, that is 10. We are remaining with 16. So where will 16 go? So we will have 3s, 3s2, so those are 12, and then now you come to 3p, 3p4, like that one. Because remember, now we are going to remain with only 4 electrons, and all those electrons will go to the 3p orbital, the 3p orbital. What about now the inbox electron arrangement, where we are using arrows to represent that information? This is here. So this is 1s. We have 1s. We have 2s. 2p, 3s, 3p. Don't know if people are seeing to that far end. So this is complete. This is complete also. This is complete. We subdivide it into 3 portions, like that, like that, like that, because they are complete. This one is complete. This one subdivided into 3 portions. You should not repeat the mistake I've done here. First, split the electrons singly, give 1 single electron per division, and then you start pairing like that. That is the inbox electron arrangement. So I believe I can do another mistake. So the next thing you need to take into consideration, this we are saying now, the electrons which are represented by arrows, the arrows must, if we are bearing, we must have those 2 electrons being in opposite directions, because we are saying if they are in the same direction, we will have high electron repulsion. So that's why they are in opposite directions. They are in opposite directions. So, and then we are saying the lowest energy levels are being filled first before you proceed to you start from n is equals to 1, filling them downwards like that. And I think those are the rules people, all the grade 10 learners, need to know. So somebody saying we do one example, and that is for when n is equals to what if now we have an atom which has when we have an atom x which has atomic number 3, s which is atomic number 3, you can be able to see we are going to have only 1s and 2s. So 1s, 2, and then we have 2s, 1. What if now we have y, and y is not the actual symbol of an element, being 11. So we are going to have 1s2, 2s2, 3, 2p6, and then you don't write like that, you'll be counter checking to see how many electrons are there. So we have 10, and then we will have 3s1. So feel free, that's in for today. We will continue from there with these ones, and then we are going to see the ions, the electronic configuration using SPDF, orbitals for ions and also for atoms. That is what we have covered. Make sure you know the difference between an energy level and the orbital. Remember the broad area where an electron is likely to be found, a broad area around the nucleus where an electron is likely to be found, is what we call the energy level. And these energy levels are being subdivided into sub-levels, and the sub-levels is where the orbitals are likely to be found. Told you an orbital is a specific area around the nucleus where an electron with a certain energy is likely to be found, and these orbitals are being represented by lowercase letters S, P, D, F, S, P, D, and F. So, and then I think that's enough for today. Any questions, I'll be taking in any questions. If people have questions, they feel free to ask. Bye bye.